Welcome back to Tea with Carl. You know, I was thinking about what we said last time, and I've been sitting here meditating on these two cards, two aces. It's such a powerful hand. It fills you with confidence. You've got a nice stack of chips in front of you. You've got a pair of aces. How can you lose? Nobody can be that confident. So you start, and before long, a few people stay in with you. It's a little bit worrying, but still, nonetheless, there's nothing down. You feel confident. Now, the thing is, you mustn't let anybody know how confident you are, because you want to maximize your return. But the point is, that feeling of confidence. And how many times have I watched games where a person with a pair of aces has lost for one reason? Because these two aces hold a great power. They hold the power to win a lot, and they hold the power to lose a lot. And people can pick up on that. And what often happens is the player with a pair of aces can't let them go. He must have a strong hand. He ends up, or she, doesn't matter who, going all in, putting all their chips in the middle, and they lose. For one reason, they can't let go of the aces. I want you to think about that as a metaphor that we carry over to every other area. So now, supposing you're thinking of relativity, which is the theory of the very large scale with specific reference to gravity, which was our starting point. And there was a scientist a long time ago who was asked, can you sum up the theory of relativity when it was fairly brand new in a few words? And he said, yes, space-time commands and matter acts. And this was a brand new thing. Except it wasn't really. Because if you think carefully about what was said in that statement, it's like an upgrade of the principle of inertia. It still maintains that matter is inert, but what moves it around is space-time. And the pair of aces, in terms of physics, is space-time. Now, when you look at modern critiques of science, you will find that there is generally a consensus of feeling that there's something wrong with the mechanistic point of view and so on and so forth. But even so, amongst those scientists, even though they know that there is a flaw there somewhere, they can't let go of space-time, which by inheritance means they can't let go of the principle of inertia. What is it about space-time that makes it so difficult, to put those aces down? This is a difficult question in some respects, because nobody does it, so we're not familiar with it. And the unfamiliar is like unknown territory. Well, we're going to look at that next time in a little bit more detail, especially with reference to what other people have been saying about it. And it may have some surprises in store. So, till next time.